All right, we got one more section. Shouldn't take all that long. We can model with linear functions. And that's what we should be able to do. So we're going to get a real-world situation that has to do with a linear graph, and we're going to limit the domain and graph it. And kind of the culmination of everything that we just did, the last section. You guys don't notice that most of the time when you do math, they end up with word problems, and people get in the habit of stopping when they get to word problems. Don't. The word problems are kind of a way to make sure that your mind truly understands something. So go through, put it in context. Don't stop because it gets a little harder. This won't be too bad anyway. So recall that when a real-world situation involves a constant rate of change, I'm going to put a little m over there so we can just hear constant rate of change and think slope. A linear function is a reasonable model for this situation. This situation may require restricting the function's domain. Obviously, my copy here is cut off. Yours probably wouldn't be. Write a function that models a given situation. Determine the domain from a given situation. Graph the function using that domain and identify the range. All right, so here we go. It says Joyce jogs a rate of 1 mile every 10 minutes for a total of 40 minutes. So we kind of get that we're not going past 40 minutes. So my guess is that when I come down here to my graph, my domain is going to be in minutes. And somewhere around here, I'm going to stop, right? She starts running here, stops here. So we're going to use inequalities. That's telling us how to write domain and range. All right. And we're going to identify this. So identify the independent and dependent variables. So, well, my independent is x and y. And let's see what they are. Well, my x is time, which I can see down here. So my independent variable is time. My dependent variable, which is the y, looks to be distance. I'm just going to write miles. All right. So my rate of change. Let's think about what that is. Let's write it like it is. It's slope, which is delta y, my change in y, over delta x. And in this case, we know y is miles. How many miles go by? And time is minutes. Every minute. I should probably put minutes up there. So if those are our unit rates, it looks like our change is 1 mile every 10 minutes, right? She runs 6 miles an hour, which isn't too bad. All right. So we find the y-intercept. Well, we can pretty much assure that after 0 minutes, she's gone 0 miles. So my y-intercept is 0 right here. She, in fact, touches that. So I'm going to make that hard circle right there and write the domain. Well, since our domain is minutes, all right, we're representing that with x. It says write it as an inequality, so we can be equal to 0. And everything in between 0 and 40, that is my domain. Graph the function. Well, let's write this. We're going to write this as f of x, that's our y, is equal to, we already said our slope was 1 mile every 10 minutes times x. All right, that's how much time goes by. And let's figure it out. What if I plugged in a 40? So I'm going to come over here and plug in 40. What is f of 40? Most of you already know, right? That's 1/10 times an input of 40, right? So f of 40, when my input is 40 minutes, my output is, well, 1/10 of 40 is 4. So when I plug in 40, I get 4 out. So I come over here and I'm going to put 4 out right here. And I do, in fact, touch that. All right, so I got my y-intercept is 0, and I plug in 40 here. I get 4, and it's everything in between here. That is her distance in relation to time. So my range, let's talk about our range. Our y is at least equal to 0, and may also be equal to 4. And there it is. Not too bad, right? Let's do one more together, and then I'm going to leave you the last one. This one's talking about a candle. I'm going to go ahead and put an x over here so we can think of it as x and y, or maybe even function of x and x, right? Y is the same as f of x. And it says the candle starts at 6 inches high. So I know when it hasn't burned at all, it's at 6. I'm going to go ahead and put a circle over there. and burns at a rate of 1 inch every 2 hours. So let's go talk about a few things. We know our y-intercept. That's the start, right, is 6 inches. I'll even write inches right there. And we know our slope. And let's write everything we know about slope. It is our change in y over our change in x. Let's define this based on that graph, our hints over here. So this is our change in time right here, change in time. And our y is our change in inches, And we can get our slope right now. So it says 1 inch, so we're burning. Let's assume we're going down an inch, right? It's getting smaller. And our time is 2 hours. So we get a slope of 2 hours. We can actually write this pretty easy, right? Our y is equal to negative 1/2 x plus 6. And there's an equation that represents this. So there's a couple things I can do. We realize, let's see, that we burn for 5 hours. So let's go ahead and we're going to use interval notation for my domain. We can actually burn for 0. It's okay to actually burn for 0, so we're going to say we can actually be 0 with that bracket. We can also burn for 5, right? So our domain is 0 to 5. Let's plug that in. Let's plug in 5. So if I say f of 5, remember this is kind of interchangeable with y, is equal to negative 1/2 times 5 plus 6. We'll see how low this candle gets. I should have a plus sign there. It's kind of messy. Sorry about that. So this is negative 2.5 plus 6, which is negative, or it's positive 3.5. So when I plug in 5, I get 3.5. Let's write that. F of 5, x of 5, y, or f of x of 3.5. I go over 1, 2, 3.5, and I can actually touch that. I get some graph that looks like this. We can see our candle shrinking, but we still got a little bit after 5 hours. So my range, start off with the lowest range. My lowest range over here is 3.5. We look up to our highest range. It looks like it started way up at 6 inches. And it did touch 6 inches, and there we have it. So I'm going to highlight this. It's going to give you something to talk about. And in class with your partners. And that's it. I'll see you guys.